Thanks for taking the time to dive more deeply into the different parameters of light and what makes a good photobiomodulation device. This video contains 3 parts. First, we describe the parameters of light that matter. It's tough to talk about joules and watts without understanding how they impact treatment. Second, we talk about the device classes and the real difference between Class 1, Class 3B, and Class 4 devices. Lastly, with a better understanding of the device parameters, we then look at the MedcoVet device specs and how they fit into the industry guidelines for veterinary treatment with light. So let's get started. One of the most confusing aspects of treatment with PBM is the concept of dosage. How much light is needed to achieve a positive outcome for your patients? You may have questions like, how can a 50-watt device and a 1-watt device both reasonably heal a patient? Or, does a 50-watt device treat 50 times more quickly than a 1-watt device? This video exists because for most people, talking about joules and watts just goes in one ear and out the other. We've taken a different path by following the evolution of how researchers and clinicians work together to optimize treatment with light over many decades. Our hope is that the story will help you understand all the dry terms. Although photobiomodulation started in the 60s, it took until the 1990s for PBM to move out of the research lab and into the clinic. Early adopters of PBM were looking for a way to describe the right light parameters that lead to healing in the clinic. Very early on, conventional wisdom was the more light the better. But early experiments proved this wrong. Researchers confirmed that more light isn't always better. What they learned is that there is a sweet spot of light, and too much light or too little light doesn't have a clinical effect. They described the dosage in joules, meaning power times time. For example, 10 joules may not have an effect. 10,000 joules may have a negative effect. And between 60 and 500 joules could have a positive effect. For people familiar with PBM, this is called the Arndt-Schultz law. So, for many years, dosage was described in joules. While this was better, researchers encountered a new problem. Some studies in that joule sweet spot had a clinical effect, but in other studies, it didn't. It led people to wonder if light was having a clinical effect at all. After about 10 years, the leading researchers in the field agreed that we need a new parameter to describe dosage that's better than joules. With more experiments, they confirmed that 1 second with a 60-watt light was not the same as 60 seconds with a 1-watt light. In hindsight, this isn't very surprising. If you think of a turkey, cooking at 375 degrees for 3 hours isn't the same as cooking at 3.75 degrees for 300 hours, or 3,750 degrees for 0.3 hours. The researchers needed a way to capture both intensity and intensity over time. To measure light intensity, they chose watts per centimeter squared, and to measure dosage, they decided on joules per centimeter squared. This is light intensity times time. It turns out that there is both a sweet spot in intensity and in total number of joules. One of the leaders in translating photobiomodulation from research to practice is the World Association of Laser Therapy, or WALT. WALT is a group dedicated to the efficacy of treatment with photobiomodulation. In 2012, with this new useful treatment parameter in hand, WALT made it their mission to ensure that clinical trials in PBM capture all the right parameters, so we could learn what does and what does not work. WALT mandated that any PBM study must report key parameters of the study, including wavelength, power, power density, and irradiance. Since 2012, PBM research quality has improved dramatically, with hundreds of good quality studies. With 10 years of new data, Walt assembled a team of both research and clinical experts to evaluate the literature and compare it to their experience in the clinic. Last year, Walt published proposed guidelines for veterinary medicine that capture this Joules per centimeter squared parameter and its effect on treatment. MedcoVet uses these guidelines, including the Joules per centimeter squared parameter, in our standard protocols. So let's talk about device class. As you probably know, PBM devices come in 3 basic categories: Class 1, Class 3B, and Class 4. These classes are really about safety, not power. But don't worry, I'll talk about class and power in a bit. Bear with me. In establishing classes, the FDA wanted to describe the safety of light devices so that they don't end up in the hands of someone that could be hurt by them. So they came up with classes based on the potential risk to eyes and skin. Class 1 means eye safe without goggles. A layperson can use this with very little risk. Class 3B means not eye safe without goggles, but usable with education. You can send this home with a client, but you must provide safety training. Class 4 means not eye safe without goggles and not trusted in the hands of a layperson. You don't send these devices home. So the FDA, in creating these classes, said you can send Class 1 devices home, you can send Class 3B devices home or use them in a clinic, but you must be trained about safety. And please, don't send a Class 4 device home. And make sure the person using it in clinic really knows how to protect themselves and the patient. Now, given that class is really about safety, why is the common belief that Class 4 devices are more powerful than Class 1 or Class 3B devices? Well, the easiest way to be safe is to lower the power. A laser pointer, which is 1/200th of a watt, is eye safe because it's so weak. This Class 1 device won't have a clinical effect. But here are 2 examples of Class 1 devices which have more power. A multi-radiance device has 50 watts of peak power, but superpulses the device in a way that is not harmful to the eyes. A second example is the MedcoVet device, which has 1.1 watts of power, or more than 200 times that of a laser pointer. But the optical front end diffuses the light so it can't hurt your eyes. The MedcoVet device also gets past the fur, which absorbs or reflects about 80% of the light, so more light reaches the tissue. Now, last but not least, let's talk about the MedcoVet Luma, its specs, and its dosage for clinical treatment. The MedcoVet Luma has 1.1 watts of power. Again, this makes it much more powerful than a laser pointer, but still eye safe. Remember from earlier in the video, power, or energy, isn't a good way to describe treatment or dosage. With MedcoVet, our power density is 65 milliwatts per centimeter squared, which translates to about 4 joules per centimeter squared per minute. We chose these parameters because they fit the Walt veterinary guidelines. Again, these guidelines were established by an appointed team of experts in both research and clinical practice. They suggest a power density of 50 to 100 milliwatts per centimeter squared for optimal treatment, and 3 to 5 joules per centimeter squared per spot for treatment. MedcoVet goes one step further by using these guidelines as a starting point and then tailoring treatment based on the patient response. We hope this video helped you understand why different parameters evolved over time to describe dosage for photobiomodulation and how much PBM guidelines have improved since being adopted in veterinary medicine. Our hope is that as our understanding of light and healing improves, PBM will reach mainstream adoption alongside other conventional treatments. If you have any questions, drop us a line at support@medcovet.com, and we'd be happy to continue the conversation.